Alright, so the next thing we're going to talk about are student t-tests. I know I introduced them with the confidence intervals in the last video, and so now we're going to talk about using those student t-tests to do a variety of things. You can use it for a bunch of different things. We're going to talk about 3 things. So comparing, it's good for comparing means, different means. How are these means significantly different for these 2 different groups of measurements, or are they statistically not different? So the first thing we're going to talk about is comparing your measurements against a standard. So say you have measured, you're going to measure lead in soils. Well, you want to make sure that your method is actually going to give you the right thing. So you go down to NIST, you buy a standard, a NIST standard with a known concentration of lead, and then you analyze it, and you analyze your samples, and then you figure out whether your method is giving you values that are similar to the NIST values. Okay, so then the second use that we're going to talk about is comparing replicate measurements for 2 different methods. So you have the same sample, you're going to measure it by 2 different methods several different times. So if you want to know if XRF or AA is going to be a better method for you to measure lead using, then that's the type of thing that you might do. And you would use the same sample for that, and you would measure it multiple times. The third thing we're going to talk about is using several individual measurements measuring the same sample, 2 different methods, and comparing those methods, whether they're giving you significantly different or significantly different results. So, number 1, comparing your measurements with a standard. You're going to use the same equation, x bar plus or minus ts over the square root of n. So the example in your book, we're just going to go over the example in your book where you have a NIST standard that's 3.19% sulfur, weight percent sulfur. Your data you come up with is 3.26 plus or minus 0.06, which gives you a range of 195 to I said that totally wrong. 3.195 to 3.325. And so if the range of your data includes the known value, there is no statistical difference. However, you can see that the lower limit is actually a little bit higher than what the NIST standard is. And so actually this is because the NIST standard value does not lie within the range of your data. There is a statistical difference, and you need to go back to the drawing board and figure out how to make your method more precise or more accurate. But in this case, more accurate. So here's the second one, where we're comparing replicate measurements of the same sample using 2 different methods. So here, you're going to calculate a t-value, and then you're going to compare it to the t-value that you would find in the table for your desired confidence interval. So you just do mean 1 minus mean 2 over S pooled times the square root of n1 times n2 over n1 plus n2. So these are equations. Obviously, you're not going to remember them. You can just look them up or write them. You're going to want to write them down, and then you can use them on the quiz and on the exam. So S pooled equals, so you're going to you still need to calculate this S pooled. So S pooled equals the square root of x1 minus, or xi minus x bar squared for every measurement for both set 1 and set 2 of the measurements, and then n1 plus n2 minus 2. So for degrees of freedom. So it's just calculating your combined standard deviation. And so then if your calculated t is less than the t that you find in the table, then there's no significant difference between the 2 different methods. So the third example that we're going to look at today is comparing individual measurements made using the 2 different methods on many samples. So say you have a ton of water samples that you want to get analyzed, and you only have a finite budget. And this type of stuff happens all the time. Well, this is a method for being able to analyze each sample via 2 different methods only one time, so no replicate samples, or no replicate measurements. And you're going to try to figure out if method 1 or method 2 is better, or if they're significantly different. So, you calculate your standard deviation for the difference. Your book actually has a great illustration of this, but basically you take each measurement minus each measurement x1 minus x2, so method 1, method 2, and then that gives you the difference. So then you take each of the differences minus the the mean of the differences. So you add up all these differences and get a mean, and then you square them and then divide by n-1 square root to get your standard deviation of the differences. All right, then you calculate t-calc by the same thing, the absolute value of the mean of the differences divided by the standard deviation of the differences times the square root of n. So if the t-calc is greater than the t-table, there's no significant difference. And we'll do you'll have plenty of opportunity to practice figuring out which test to use, and also practice using these equations in class.